So guys, sadly, I had not so much luck and I was experimenting too much and I screwed up the project. So that's also a reason why the series is a bit delayed and I was not able to review the C++ part because I had not a running system. So yeah, somehow the editor decides to stop with an assertion. But yeah, that's how it is. So for that, I'm always doing backups, so I would recommend to you as well that you also do backups and maybe start using Git. It helps a lot to keep your work organized and safe. But yeah, the next topic I want to discuss very quickly is thank you so much, guys, for the support and feedback. I already saw that I have 11 stars on the project, even it is a very young project. So when did it started? When I pushed the stuff at first. So June. So it's 1 month basically. 1 month. 20 May was the first when I started to commit stuff for this. So yeah, thanks a lot for the feedback. And also, which I really enjoy, is if you go into the pull request. Here we currently review Unweighted Bones directly in Unreal Engine. And there I also got some feedback from a guy. And yeah, so for that, most of the time I'm doing a love or rocket or so. I really enjoy emojis. So yeah, you will see them a lot when you talk to me. But yeah, anyways, thank you so much for the feedback. And also what I did, I introduced a little bit more in this pull request. So yeah, normally we have to review this again, but it's fine because it's basically just adding a data table rows to make this Miximo character working. So if you have not seen this series yet, you might be really interested into this if you started follow me, because here I try to get a Miximo character working without renaming bones, and I was using the tools we currently review to introduce a root bone and unweighted bones. And then I had some challenges. As you might see, here is quite a lot of videos where I go through all the steps, and I got him almost working. So yeah, I will leave in the comment in the description below a link to this series, and I hope you really enjoy it. But yeah, that's the topics I want to cover quickly. So we move on to the review. So here I would say let's scroll up a little bit. So we reviewed already the blueprint parts. So that's viewed. Okay, bone chains viewed, unweighted bone stuff viewed. There was a change. I did some fixes here. Virtual bone stuff. Yeah. We viewed the blueprint stuff. So that's fine. We will skip this C++ part a little bit because I'm more interested into the header files at first when I do reviews. But for here we can quickly review this. So I noticed that if you try to add constrained bones and modified bones, that it's not checked that that's a valid bone name. And a valid bone name is returned if you have an index which is greater than or equal than 0. But here index none is -1 basically. So that's why I introduced some error messages here. And also sadly, Achim, you forgot to remove the comments. Remove commented code. So let's see, is there already? Nope, I did not yet use this. So there's basically a shortcut in GitHub where you can introduce the messages you use a lot quite quickly with this shortcut, but I did not set this up yet. Remove commented code, something like this. So we copy this into the clipboard, so that's fine. And then we raise an error message and go on. So I always try to go on and show all the errors to the user and then return, for example, with a false, which you should see here. So here's blah blah blah, some constraint, there's a typo. Some constraint bones. So here I really love this one because you can directly see what is the issue, and then you can later, when you rework the findings or integrate the findings, you can directly see this. Or there's also a possibility where you can say add suggestion to batch, and then you can create a new commit directly here on GitHub without touching the project locally. Some constraint bones could not be set up. No constraining will be done. Please check the error messages above. That's not correctly. That's not correctly or completely. Yeah, it's a bit misleading. No constraining for those bones will be done. Please check the error messages above. So I like this more. So yeah, if you find the misleading error messages, feel free to raise also a pull request and give me some feedback. Then we can improve the tooling so that it helps everyone. But yeah, anyways, there I'm wondering a little bit because let me quickly check. Oh yeah, that's for the IK rig skeleton, and there we need to constrain bones as well. So I was not completely correct what I said before. That's a void on initialize function, which is not return anything. It just shows the error messages and will not add those bones. So yeah, that still needs to improve. There's a silent error. Here we can say consider to improve the error handling here and return if and make sure that really nothing is done here. So yeah, this is a task. I really like this one from GitHub. Improve error handling. So yeah, let's say we have seen this one, which is okay-ish but not perfect. Of course, it's more like a prototype or experimental version here, so we can say we viewed this. But yeah, let's go on. It's a lot of code we have to cover today. Let's go on with the header file. So oh yeah, we can also say the build file is fine because there was just application core extended with render core that is needed if you want to introduce unweighted bones in Unreal Engine. So we can say we viewed this, so that's fine. And here on the header file, there we worked a lot already and introduced custom functions. And to make it more streamlined and more straightforward, I introduced new structures which can handle the new bone name, the parent bone name, and the one you want to constrain it to. So basically that's needed if you introduce an unweighted bone. You can say the parent, then basically the name of it and where you want to constrain it to. And yeah, that can be set up with a data table, which we already have seen in the editor in the video before. Then we also have a new structure here. We can say that we want to constrain bones. Here's the modified bone for the bone that currently needs to be touched and the one we want to constrain it to. And for that, sadly, there's no documentation for it. Please add documentation for the new structures. I know I did not really cover documentation so far, but as we do a review here and the system gets more and more complex, it would be very nice to have some meaningful descriptions of those values. Same for here. So we can just go here, edit, copy, paste, or only copy, and here we can say paste. So yeah, as you see, this is a lot of work is left to make the pull request clean and straightforward. So, and yeah, to make this feature possible or available, there is a new function which is also blueprint callable, and which is called add unweighted bone. Here again, there's no documentation. Please add documentation here so that we know what this function does. But basically, if we can read, we see that we want to add an unweighted bone, and here we have the array which we want to use, and it should be in a parent-child structure, so basically chains. And then we also need to give the function the skeleton, so that the function knows which skeleton needs to be touched and also the connected meshes. So, and then also there we have a new function as well where we can say constrain bones for skeleton pose. Here's also no documentation. So and here we use the structure which we have seen before, so it's basically this one here. I used _bp because it's exported to blueprints. It's just naming convention, which I liked. Maybe I wouldn't like it in the future, but here it's fine. And then we here say the constraint bones and also the skeleton. Then we edit the pose here directly in C++. That's not possible in blueprints, but we can write small functions to expose this feature to blueprints, and then we can use it there as well. And yeah, for the Miximo characters, that's why it is here. We also need to introduce a root bone because those characters does not come with root bones. And for getting it properly to work in Unreal Engine with root motion, we need a root bone. And yeah, as you might know, it's quite painful to get it done in Blender if you're not familiar with Blender, or you're having import and export issues and a lot of stuff. So that's why I decided if we can add unweighted bones, because it's quite similar, we also want to add root bones. So here also, cancel, no documentation available. Please add documentation here. Let me copy this to the clipboard, and here I did something wrong. Same here. So we have add unweighted bone. Here I did not copy the right one, so let's make it more clean. So, and yeah, here's another function which we already have seen in the blueprint review. Here we can request animation recompression, and that helps if you want to reconstrain the virtual bones in your animation sequences. And yeah, that's quite helpful, and also sadly not available for pure blueprint functions or pure blueprint projects. So that's why I decided to expose it as well, so that we can use utilities and yeah, speed up the script creation in Unreal Engine so that we don't have to recompile stuff. And also, maybe you are not familiar with C++ so much. That's why I decided to make this available for everyone who only codes in blueprints. If the developer is currently working on the Windows, we do not have yet Linux build. So let me see. So we review this file, which is fine. So now we come to the complex code. So that's quite a lot to review. It's quite a huge pull request. So let me see where we can start. So here we have the request animation recompression function. What we do is the following: we get a skeleton. There is no check for the skeleton. Check if skeleton is valid. So that is missing here. Hold on, wait, let me move this up. So can we delete this again? Yes, we can. Yes, we can. So that is missing. But what the function does is the following: it uses the asset registry, and we can get it the following. That's what I learned from Unreal Engine. So you say add module manager load module checked, then you say the class, that's f asset register module, and then you need also give the name asset registry and say get. Then you can save this in the e asset registry interface, and you can use a reference here to not copy the stuff, because that's not allowed in this case. But here I'm using not my coding conventions. So normally local variables start with a small letter, not with a capital one. And then we can ask this asset registry to get assets by class. So basically what we want to get is animation sequences, and there you can say animation sequence : static class points to f name, because that's the asset name. And then we give this array which we have defined here, assets, and then we will get a lot of assets. And yeah, to make sure that it is only an animation sequence, we cast this one. So we say anim sequence and say asset, because that's a for loop, get asset, and then we iterate all over them, and we cast if the cast is not failing. So if it is true basically, then we can say anim sequence points to get skeleton f name, and then we also check if the skeleton name is the same. And then we can call this method here, request async anim recompression, and then it will asynchronously process all animation sequences. And this might take some time, but it saves you the headache to shut down the editor and restart it again if the virtual bones are not constrained. So you can just do right click later if the pull request is done on the skeleton asset, and then re-trigger this for all linked animation sequences. So basically this is quite fine for me, the implementation, and we can move on to the next implementation. But wait, so here that does not look great. So header files should be included at the beginning of the CPP file. So here say move header files to the top of the CPP file. That's how we code, not like this. So yeah, here I was going forward very fast and wrote a lot of dirty code to get the system working, and to know if the proof if the system works or the proof of concept is correct. So it's basically a minimal viable product, but it's not that great, and it does not scale, but it works for our use cases, and I was able to get the maximum character working. So yeah, but that's why we do reviews, and for reviews I also do or explain the code most of the time with the developers and so on, and ask questions a lot. So here I cannot ask myself questions, but it's also quite interesting to review the code later if you have written it some days ago, and then move on basically with other topics and come back to it later. So what we also have seen here is the class which we reviewed before. So here are some new include files, which is fine in the Unreal Engine include section. So here we need to include skeleton mesh socket, skeleton mesh model, IK rig definition, the rig editor to get the controller, filter stuff for the registry module, and so on, a lot of stuff. Then also for this platform miscellaneous stuff, I think that was for the clipboard stuff, I don't remember anymore, but if the include file would not be there, then we would not need it. But anyways, we move on, and also here is a new helper function which is also defined at the top, but I prefer to do the following with those files or with those helper functions. Only introduce the function prototype here, move the implementation to the end of the CPP file. That's how I code, to make it more structured. But here we can also have a quick look, and it's the same error. So skeleton is not checked. Check if skeleton, can also use this one here, is valid. So, and what I also do sometimes is using those signs here. because then you can click on preview and you get a highlight, basically highlighting the text. So it's text formatting, and then you can see here skeleton, so that then I know what is meant here immediately. Here also we have an array with skeleton mesh, pointers, the filter stuff. Then we say skeleton mesh, colon, static class, get the name from this asset. And then we add this to the class names. Then we want to say that we want to search recursively. And here we are getting a skeleton string, which we need later on. Let me check when this is needed. Oh yeah, that's basically, this filter stuff is quite complex. I did not get how it completely works, but you can say add, then you can say member name and a skeleton string, and then it kind of works. Yeah, it's quite interesting, but it works. Then you can do the following. You can define a new asset array, and if you have found this one, basically you cast it again to skeleton mesh. If you say get asset, and if this is correct, we add this to the skeleton meshes array, and later we return this one. So the function is looking okay for me. There is no issue except these ones above, so that's fine, we can move on. But here, this one, skeleton reference pose, when I was coding this, I had the issue that if you want to edit the pose of a skeleton asset, there is basically no clean API where you can calculate the local rotations and or transformations to world space. And for that, I introduced this new helper class, but I don't like this solution because it's a lot of work and it's a lot of stuff for us to maintain. And I was wondering, which we add here, is it possible to reuse an engine class here? Because that would reduce the maintainability of the tooling for us, because then Epic will take care about this. Otherwise, we here need to calculate the bone rotations and convert them from local space here. Basically, we saw here the local spaces, and then we need to calculate the world transforms. Here also we have an enumeration where we which we can use if we want to say set pose. Then we can set the local space or world space, and also here's no error message, of course. That's what we can write at the top of the file. Remove all to-dos from this file. Remove all to-dos, because then we get clean code, and also valuable error messages if something is going wrong. But set pose is working the following. We try to ask from the reference skeleton if the bone is available, and if it is available, we check if it is a local transform. Then we can assign it directly with this index, or if it's not a local transform, we need to calculate the world spaces, and for that we get the parent index from the bone, and if the bone is not equal to index none, we use the world space array. Otherwise, we assign an identity here and use this parent transform, because for the root bone that's not possible to set the world space with a parent. So this is the identity transform, and then you can say transform get relative transform from the parent transform, and then you can assign this to the local poses. And then again, we need to recalculate the world space transforms. And we can also do the following. If we want to get a transform from this system, we ask for the bone name, of course, and which space we want to use. And if nothing is given to the function, we only use the local space. And for that, we also search for the bone. If it is index none, not available, then we return the identity transform. If it is available and we are in local space, we return the local space transform from the array or the world space poses from the array. And these are stored basically in those members here. And also, if we want to set up the class, we need to give the class a reference skeleton, because then we know the transforms basically. And also here, calculate world space transforms. That's an array here which is the same size as local spaces, so basically for every bone, and we mark this. If it is true, then we process this already. If not, then we skip it. So far I remember. No, I was wrong. We don't skip it, we just have this for, it's basically a check for debugging. If every array element is true, we know that we processed all bones. That's why I said we should not try to reinvent the wheel if there is already a class in Unreal Engine which does the job for us as well, because normally you have to work a lot with skeleton meshes, and there should be something similar with those local spaces and world spaces, because it's always the same calculation. And how the function works is we basically increase the size of those arrays. Here also I did not follow my coding conventions. It should be start with a small one. Here as well. I think I will drop this code anyway and try to get it done with an engine class, but let me explain how it works. So we also increase the world spaces from the local spaces, because that's what we already got in the constructor of this class. This should be here. I did not cover this one, but it's basically the same. We just ask the reference skeleton, get all local transforms and store them in this array, and then we recalculate the world space transforms basically. So we cache them here. How the loop works is following. We get the parent index. If it is not equal to index none, we can say local space pose multiplied by world space poses with the parent index, then we get the world space for this bone. Or if it is the root bone has index none, we will just assign this local transform. So that's the function we already covered. For the add unweighted bone, I think we need to create a new video, because that's quite overwhelming and a lot of stuff, and the video here is getting quite long. So see you in the next session.